In this next section, 4.03, I want to get into the properties of logarithms, which were laid down in section 2, but I didn't do it on this tape. They were kind of developed in the handout of section 4.02. Let me do two quick properties with you. Two quick problems. If I wanted to take the log of 30, and I'll need your help for this, to do the log of 30, and then I would like to get the log of 3 and the log of 10.
1.47.
All right, what's the log of 30?
1.48.
One.
I'm going to round it up. It's 1.
Round it off, yeah.
1.48.
1.48. Okay. And now what's the log of 3? Round it off. 0.48. And what's the log of 10? 1. Isn't that interesting? Did you notice that if I took 3 times 10, I get 30? And did you also notice that if I add 1 plus 0.48, I get 1.48? Interesting? Let's try another one. I want to do one with ln of 30. And I'd like to do the ln of 3 and the ln of 10. Can you help me out with that? What's the ln of 30? 1.48.
Yeah.
No, I don't think so. ln of 30. ln of 30. What is it?
3.4.
3.4. 3.4. Now what's the ln of 3? 1.1. And what's the ln of 10? 2.3. Is that neat? Did you notice that this plus this equals that? This plus this equals that. And therefore I could say this equals this plus that. I could say this log of 30 equals log of 3 plus log of 10. I could say the ln of 30 equals the ln of 3 plus the ln of 10, couldn't I? Okay? In other words, if you could factor this down, we'd have this property. Now, I'm not proving the property. The property is proved for you on the first page of section 4.03. It's proven there for you. And so I'm not going to try to get into the mathematical proof of this, but I want you to get a sense of this property and how to use it. It says, if you have the log of a product of numbers, like let's say the log of mn, the log of a product of two numbers, like in this case it's going to be what? 3 times 10. 30 is 3 times 10. If I have a log of a product, then what it turns out to be is the log of the first number, m, plus the log of the second number, n. Okay? Now remember what a logarithm is. Let's go back to the basic definition of logarithms. The basic definition of logarithms said log base y equals log base b of x. Y equals log base b of x. What it means is b to the y equals x. b to the y equals x. Remember that? The basic definition of logarithms. So now what I'm saying here is, what is a logarithm? Well, y is a logarithm, isn't it? Y equals log base b of x. So y is a logarithm. And what is this? Y, in this problem right there, that y is the exponent, right? So what a logarithm is, if you want an informal definition that everybody can understand, a logarithm is really like an exponent. Remember the very first problem I did when I introduced this to you? I think it was log base 3 of 9. Log base 3 of 9. And you remember what the answer was? 3 to the what power equals 9? 3 to the second power is 9, right? So in other words, when we say, what is the log of 9 to the base 3? We're saying, what is the power? What is the power? What is the exponent? The exponent would be, of course, 2, right? What is the exponent? The exponent is 2. So a logarithm is like an exponent. And what we're going to have to do to prove the laws of logarithms, we're really going to be using the laws of exponents. If you can keep that in mind, that a logarithm is like an exponent. So if I have, what was the law of exponent? What is it when you multiply? When you multiply with the same base number, you do what to the exponents? When you multiply, you add exponents, right? When you multiply with the same base number, you add exponents. When you multiply here, you add logarithms. You add exponents. Exponents are like logarithms, right? So it makes sense that when you multiply, you add logarithms, just like when you multiply, you add exponents. And I'm trying to give you that sort of an informal sense of this. Now, to be perfectly up to snuff on this thing, we need to prove it mathematically, but I'm not going to take time to do that right here. The mathematical proof is in the book on the first page.